Who controls the minerals that power the modern world? Modern life depends on materials that most people rarely think about. Phones, computers, electric vehicles, electricity networks, wind turbines, aircraft, medical equipment, satellites, and industrial machines all require specific minerals. These materials include copper, lithium, nickel, cobalt, graphite, and rare earth elements. They are often called critical minerals. The word critical does not mean that every mineral is rare. It means that the mineral is important to the economy, technology, energy, or national security, while its supply may be difficult to replace or protect. This creates an important question. Who controls the minerals that power the modern world? Is it the countries where the minerals are found? The companies that extract them? The facilities that process them? The manufacturers that turn them into batteries, magnets, wires, and electronic components? Or the governments and markets that influence their price and movement? There is no single answer. As with oil, owning a natural resource is not the same as controlling the entire system. A mineral can be extracted in one country, processed in another, turned into a component somewhere else, and used in a final product on another continent. Control is divided across the whole supply chain. To understand this system, we must begin with the minerals themselves. Copper is essential for electricity. It is used in power networks, buildings, vehicles, motors, and electronic equipment. Lithium, nickel, cobalt, and graphite are important materials in many battery technologies. Rare earth elements are used in permanent magnets found in electric motors, wind turbines, electronics, and advanced industrial equipment. Other minerals support semiconductors, aerospace systems, telecommunications, and specialized manufacturing. As the world uses more electricity, digital technology, and energy storage, demand for many of these materials is expected to grow. Current projections indicate that demand for several major energy-related minerals could rise significantly over the coming decades. Lithium is expected to experience some of the strongest growth, while demand for copper, graphite, nickel, and rare earth elements is also expected to increase. But growing demand does not automatically create a secure supply. The first stage is mining. Mineral deposits are not distributed equally around the world. Some countries have large copper resources. Others have major lithium deposits. Some regions produce much of the world's nickel, cobalt, graphite, or rare earth elements. This gives mining countries an important position. They can issue licenses, collect taxes, change export rules, and decide how quickly new projects are approved. They may also require companies to process part of the material inside the country before exporting it. However, having minerals underground does not guarantee control. A deposit has no industrial value until it can be discovered, measured, financed, approved, extracted, and transported. Opening a mine can take many years. It requires geological research, machinery, energy, water, workers, roads, railways, ports, and large amounts of capital. A project may contain valuable minerals but still remain undeveloped because production is too expensive. Local opposition, environmental risks, political instability, weak infrastructure, or low market prices can also delay a mine. This means mineral power depends on more than geology. It also depends on finance, technology, infrastructure, law, and time. After extraction, the material is usually not ready for use. Ore must be crushed, separated, concentrated, purified, and refined. These stages can be more important than mining itself. A country may produce a large amount of raw material, but depend on foreign facilities to convert it into a useful industrial product. This is where the difference between ownership and control becomes clearer. Mining controls access to the raw resource. Processing controls whether that resource can enter modern industry. Refining facilities require technical knowledge, reliable energy, chemical systems, specialized equipment, skilled workers, and established customers. Building them is expensive. Operating them efficiently can be difficult. Some processes also create waste, emissions, and water risks. For these reasons, processing capacity has become concentrated in a small number of locations. The concentration of refining is currently greater than the concentration of mining for several important minerals. The leading processing countries hold dominant positions in battery-grade graphite, rare earth elements, lithium, cobalt, and other strategic materials. This concentration creates efficiency. Large industrial networks can reduce costs. Refineries can operate near component factories. Suppliers, workers, laboratories, transportation systems, and customers can develop around the same production centers. But the same concentration also creates vulnerability. If a major processing center stops operating, the rest of the world may not have enough alternative capacity. The original cause could be a natural disaster, technical accident, energy shortage, trade restriction, political conflict, or transportation problem. The result could spread across many industries. A mineral supply problem does not remain inside the mining sector. It can affect vehicle production, electricity equipment, electronics, construction, defense manufacturing, and energy storage. Even when global supply appears sufficient, the system can still be fragile. Total production numbers may suggest that enough material exists, but the material may be located in the wrong place. It may not have the correct quality, it may not be processed into the required form, or it may depend on one dominant supplier. Analysis of future supply chains shows that removing the largest supplier from the market could leave major shortages in several minerals even when the normal global balance appears adequate. Transportation is another part of control. Minerals move by road, rail, ship, and sometimes through several countries before reaching a factory. A mine may depend on one railway. A processing center may depend on one port. A manufacturer may depend on deliveries from a limited number of suppliers. Any interruption can increase costs and delay production. Unlike oil, many minerals cannot move through pipelines. They must be stored, packed, loaded, and transported as physical cargo. Some materials also require special handling. The final destination is not always flexible. A particular factory may need a material with an exact level of purity, size, chemical structure, or performance. Another supplier may not be able to replace it immediately. This gives specialized producers additional influence. Control also exists in technology. Companies and countries that design processing systems, battery materials, permanent magnets, power electronics, and advanced components can capture more value than those exporting raw ore. The same mineral can have very different economic value at each stage. Raw material has one price. Refined material has a higher level of usefulness. A battery component, magnet, semiconductor input, or advanced industrial product may have much greater value. The supply chain therefore forms a ladder. Mining is the first step. Refining, component production, engineering, and manufacturing are higher steps. Countries that remain only raw material exporters may receive revenue from mining but still depend on others for technology and finished products. This is why many governments want more domestic processing. They do not want only to extract minerals. They want to refine them, manufacture components, develop technical knowledge, and create industrial employment. But building a complete supply chain is difficult. New facilities outside established production centers can have higher costs. They may lack trained workers, local suppliers, stable demand, or competitive energy prices. According to current analysis, mining and refining projects outside dominant production centers can require significantly higher capital expenditure. Price is another source of power and risk. High prices encourage investment. They can make new mines and processing facilities profitable. But they also raise costs for manufacturers and consumers. Low prices reduce material costs. However, they can discourage investment in new supply. This creates a difficult cycle. When prices rise, companies announce new projects. Because mines take years to develop, new production may arrive after the market has changed. Supply can then grow faster than demand. Prices fall. Investment slows. Several years later, demand may increase again, but too few projects are ready. The market becomes tight once more. This cycle makes long-term planning difficult. It also means that a country can have large reserves without immediately becoming a powerful producer. Current production, processing capacity, cost, and customer relationships may matter more than the total amount underground. Governments influence the system through permits, taxes, subsidies, environmental rules, trade agreements, strategic reserves, and export controls. An export restriction can reduce the amount of a mineral available to foreign buyers. A government may use such a measure to protect domestic industries, support local processing, influence prices, or respond to political pressure. Export controls on critical minerals and processing technologies have expanded in recent years, increasing concern about supply security. However, export restrictions can also produce unintended effects. Buyers may search for alternative suppliers. Other countries may invest in new mines and refineries. Manufacturers may redesign products to use less of the restricted material. Recycling may become more attractive. A restriction can create short-term influence while encouraging long-term competition. Recycling is therefore becoming an important part of the system. Batteries, motors, electronics, cables, and industrial equipment contain materials that can be recovered. Recycling can reduce waste and lower dependence on newly mined supply. It can also create a domestic source of materials for countries with limited mineral reserves. But recycling cannot immediately replace mining. Many products remain in use for years before reaching the end of their lives. Collection systems are incomplete. Materials can be difficult to separate. Some quantities are lost during processing. Demand is also growing faster than the available stock of used products in many sectors. For the foreseeable future, the world will need both new mining and greater recycling. Substitution offers another possible response. Engineers can sometimes replace one material with another. Battery designs can change. Motors can use different technologies. Manufacturers can reduce the amount of a costly mineral in each product. But substitution has limits. A replacement may be more expensive. It may reduce performance. It may require new factories. It may also create dependence on a different mineral. There is rarely a simple solution. Environmental and social conditions also shape control. Mining and processing can use large amounts of energy and water. They can create waste and affect nearby communities. Poorly managed projects can cause long-term damage. Strict standards can reduce these risks, but they may increase costs and lengthen approval times. Weak standards may allow faster production, but they can create environmental, legal, and social problems. Consumers and governments increasingly want materials that can be traced to responsible sources. This creates demand for systems that track where a mineral was mined, how it was processed, and under what conditions it entered the market. So who controls the minerals that power the modern world? Mining countries control access to deposits. Mining companies control extraction, knowledge, and production. Processing centers control the conversion of raw material into usable forms. Manufacturers control component design and industrial demand. Transportation networks control movement. Financial markets influence prices and investment. Governments influence permits, trade, and strategic policy. Consumers influence demand through the technologies they purchase and use. Recycling companies can return materials to the supply chain. No single group controls the entire system. Real power comes from controlling several stages at the same time. A country with minerals but no processing capacity has limited control. A country with refineries but no reliable supply remains vulnerable. A manufacturer with advanced technology but only one supplier faces risk. A secure system requires resources, processing, transportation, knowledge, capital, and customers. The future competition over critical minerals will not be only a competition for mines. It will also be a competition for refineries, factories, technology, infrastructure, skilled workers, recycling systems, and long-term contracts. The central question is not simply who owns the minerals. The real question is who can turn them into the products that modern life requires. Ownership begins underground. Control continues through the entire system.